G'day everybody and welcome to this session of Azure RoundUp with the one and the only Yas, who's going to be covering off containers in Azure, and this is going to be a three-part video. So Yas, let's kick off with this first part. Thanks for doing this for us.
Hey George, hey everybody. Welcome to this episode of Azure RoundUp. We're going to cover quite a few different topics about containers and Azure and how these two are really entangled to each other. So containers are something that are widespread. Everybody is using them. People are trying to get their applications from on-premises to Azure or to any cloud provider for that matter. And the best way for them to bring their applications along with all the other dependencies and everything is to make them or sort of containerize them and bring them into cloud. So in terms of the cloud providers, it's really important to give them the ability to bring their applications and run them as a container in Azure. And for that, Azure has come a really long way. So historically, we only had one service. It was called Azure Container Services, and it sort of supported Docker, Swarm, it supported Kubernetes and DCOS, and that was it. That was the end of the support for running containers. At the time, it was pretty good considering that all the other providers were at the same level, but Azure quickly sort of evolved, and we are really proud today to be one of the forefront or one of the innovators in terms of containers and running container workloads in a cloud provider. So for you to run any sort of containers, you're going to start with somewhere to store that particular Docker or any container images that you might want to deploy into your cloud services. And for that, Azure offers Azure Container Registry, or ACR for short. ACR is a really great service compared to other providers out there, such as Docker Hub, simply because it allows you to have a really private repository that you can deploy your images into this private repository compared to the public repositories. It also has geo-replication. It means that it can sort of replicate your images into multiple parts of the wall, and depending on where you're pulling the image from, it gives you the best endpoint and best speed based on users' location. So really great way to deploy your images into different parts of the wall and then leverage those, the same ACR, but in different locations. If you wanted to have a look at a few use cases and the comparison between ACR and other services, the first thing that I mentioned before is that this is a private repository. You can lock it down. You can also make it public, but the main purpose is to lock it down to only your organization, and all the images that you push into it, they will remain safe and sound for the usage of your team or other teams within your organization. The next thing is it has a really good and seamless integration with other Azure services. So if you wanted to, for example, deploy this Docker image into Azure Container Instances or web apps or Service Fabric or AKS, there is seamless integration between ACR and all of those services, and the fact that you can simply enable your CI/CD pipeline and deploy an image from ACR very easy into those services. It gives you the really beneficial use case compared to other image registry providers such as Docker Hub. You can also perform security audits on your images. You can have third-party tools or even some of the more advanced or higher tier pricing levels. They offer you some services where you can run vulnerability scans on your images. So if someone pushes an image which exposes something which it shouldn't, or simply the image does contain a malformed file or a virus or a backdoor or whatever it might be, the security scan will definitely highlight that and allow you to go and rectify that really easy, which is super good compared to, again, other providers out there. And developer tools integration is something else that it gives it a really good benefit. So simply from your Visual Studio or from Visual Studio Code, you have the ability to push your images directly into this amazing service and store them for usage of later. So enough talking, let's jump through a quick demo. Now, there are multiple different ways you can create any resource within Azure. simply, you can come into the Azure portal. So let's say this is your Azure portal. If you wanted to, for example, create a new instance, you would basically create on add resource. You could, let's actually see whether this works. Sometimes it works, sometimes it doesn't. So we need to do container registry. It brings up the container registry for us. All right. And similar to all the other services, you need to provide your subscription, you need to provide your resource group name, a name for your registry. This needs to be unique because it gives you a unique URL, which is accessible over internet. So this needs to be a unique name. For that, you could, for example, enter your name and add a bunch of random numbers or whatever your naming convention might be in there. So at the moment, I've already have this, so that's why it doesn't allow me to create it, but we are not going to create it here. I'm just going to show you another way and a much easier way. So you create your, click on the location dropdown, select your preferred location, you select your pricing tier, and there are 3 pricing tiers from basic to premium. The level of services you get obviously differs based on the level of pricing tier that you choose. If you choose a higher level, you get the ability to, for example, integrate this with your virtual networks if you wanted to lock this down to be accessible only from your virtual networks. For the encryption, it will allow you to bring your own key if you wanted to, based on the premium tier. So these are only the premium tier services. So as I mentioned, I'm not going to create this as of now here. This is just to show you can create it as part of your Azure portal. What I'm going to do here, I'm going to bring up my Visual Studio Code, which is my friend here. And what we're going to do here is that I'm going to show you how you can create and push an image into ACR. So I already have an image which I've created, and I need to deploy this image into my Azure Container Registry. I need a bunch of variables. Just I don't want to keep repeating these names and variables throughout my script. So I always create some variables for the ACR name and the location of the resource group. Then we can create the resource group. This already exists, so I'm not going to run that. And the next thing we're going to run is the creation of the ACR itself. So all you need to have is these 2 variables, or the name of the resource group that you want to deploy, and you just simply run that command, and that will enable or create your Azure Container Registry for you. Next thing you need to do is log into that Azure Container Registry. You could do that through Azure CLI. So all these scripts that I'm running are running through Azure CLI. You could do the same using Azure PowerShell. Azure CLI is much convenient for me, and it's cross-platform, so I like to use Azure CLI as much as possible for my own benefit. You can get the list of repositories that exist on that particular ACR, or you can get the login server. So this URL that you see here, this URL, this is the URL that you will use when you wanted to tag your images, because you need to tag the images based on this URL so that Docker knows where to push that particular image. So I already have an image called NinjaCat Node.js, and I want to tag it with the name of my ACR or the URL of the ACR plus NinjaCat Node.js, and the tag name will be version 1. So if I run this command, this will tag my image based on the ACR URL. And now if I just run Docker push, it will push the image to my ACR instance. Because I've already pushed it before, it goes super quick. If it's your first time, you're going to have to wait based on your image size. You might be able to wait a few minutes, and that will bring your image into the ACR and stores it there. You can have a look at your repository list. So if you have multiple repositories, this will be shown as part of the ACR repository list command. And you can also have a look at the tags that exist under that particular repository. So at the moment, we have only a v1 tag for our NinjaCat Node image. If I go back into my Azure portal and have a look at my ACR instance or Azure Container Registry instance into the repositories, you can see the NinjaCat Node.js and the version 1 And we can use this image later on to deploy other services within Azure based on this image. So let's go back into our slides and continue our module with the next service we're going to introduce, which is Azure Container Instances.
So Yas, just going to quickly ask, so with when you were talking about the image taking longer, obviously, when it initially goes up, and then for each layer after that, or each time after that, it's much faster. That's because of the layering of a container, correct? Am I saying that terminology correct?
Not the container, the images. So when you build your images, the images are built on layers, and these will help you to sort of build your images in a differential format. So you have, for example, your base layer, which is, in this case, it's a Node.js Alpine version. And then the next layer is your, for example, application layer where you copy files. The next layer contains, for example, your Node.js dependencies and so on and so forth. So next time you're going to build your images, these layers are already there in your image, and all it does is that it checks which layers are already existing, and it pushes the layers that have been updated into your registry. So that makes it a bit faster, but also if those layers already exist in the ACR, it means that if you build other images inside the same repository, those will be faster as well. So not just this tag, for all the other consequent tags, that will also work.
Okay, got it. Thanks, mate.
Not a problem, man. All right, so why I've chosen container instances. The very first thing you need to do to run a container inside Azure is to find out the runtime or the platform where you will be running your container within. Now, if you're coming from a developer background, if you're new to Azure and you wanted to just spin up something and have a play with, this service is great for you, simply because this service is the easiest and simplest way to run a container in Azure. It does have some lack of features. For example, it doesn't support custom domains. It has limited ability to run more than one container. However, if we have a look at the ease of use of this service, it makes it a great way for you to get started in Azure. So what is a container instance? If you have a look at your, for example, traditional runtimes, let's say you were running a site in IIS or Apache or whatever web server you might have. You had a runtime, and that runtime will run your application and serve that over internet or local network or whatever it might be. In terms of running a container, you need to have that image accessible when you have that, when you push that image somewhere in the image repository, and then you tell the container runtime, hey, go pull that image and create a running version of that image for me within your platform, whatever it might be again. So in this case, Azure Container Instance will pull the image from the container registry that you have provided the information to the ACI. That will create a running container of that particular image, and it will host it within the ACI instance. Now, that is only for one image. There is a workaround for running more than one image, and that's called the container group. Container group is a really great way for you to run, for example, a public container, which is accessible through internet, and a private one. Let's say you have a web application running and you wanted to keep the database container hidden from the internet, and you want to expose your front end over the net. So for that purpose, you create a container group, you deploy your images into that container group, you mark the front end public, you mark the back end private, and that will maintain the relationship between those for you. So really great way to run two containers, for example. But again, this is a limited capacity. We are not talking about orchestration here. We are not talking about having the ability to manage these containers in an advanced scenario. This is just purely for development or running small workloads within the service. So some of the use cases of the Azure Container Instances, if you wanted to run a single container, you didn't care about the custom domain, this is a service for you. If you wanted to, for example, you didn't need integration with other services within Azure, whether it's VNet integration or it's simply integrating with another service such as, I don't know, something which is not accessible over the internet. Again, this service is a great service for you because it allows you to quickly spin up a new container and run it without any dependency. If you wanted to run multiple containers in a container group or in a shared space where the containers share the same infrastructure, whether it's networking, storage, and so on and so forth, this is again a great option for you, again, considering the limitations of the ACI itself. So if we wanted to have a look at a demo of the container instances, again, we could go through the, for example, Azure portal. I'm not going to do that. I'm assuming that there will be a lot of developers watching these episodes, so I'm just going to go through Azure CLI again through the scripting to run these commands and deploy our ACI and get our image, NinjaCat image up and running. Again, we need a few variables, so these are simply the name of the resource group, the location, the ACR name, which you already have, and the resource group name that is deployed within that. If I wanted to get a list of the repositories again, I could run the ACR repository list command. It gives us a repository name, just in case you forgot the name of the repository. You could also have all the tags that are deployed. So usually what happens with running these images, if you have multiple versions or multiple tags of the same image, you need to provide a way for your services in Azure to always grab the last one. And the last is usually tagged with the latest. At the moment, I've tagged it V1 because I'm just simply trying to run these demos, and these are very simple. But what you normally can do is tag these images using multiple tags. So you have, for example, version 1 and then the latest. And then the next image that comes in, you can tag it as version 2 and the latest is going to be revoked from version 1. So you always have the latest on your latest image, and that is the tag you should be using. If we wanted to use the ACR in another service in Azure, we need to enable the admin users. This simply gives us a username and password. This, of course, is in the terms of we just relying on the username and password of the Azure Container Registry. There are other ways you could do that through, for example, system assigned managed identity or user assigned managed identity and RBAC permissions. But at this point, I'm just trying to keep this simple. Once you enable the admin user, you can query the password of that particular Azure Container Registry. Once you have the password, all you need to do is create a new container instance. So Azure AZ Container Create will create a new container instance for you. You provided a name, you provide the image name, the full image name, including the URL and the repository and the tag. You provide your requirements, so how much CPU, memory, you provide your registry name, which is the name of the registry itself. So your username is exactly the same as the registry name. You provide the password, which we just acquired. If you wanted to, you could give it a DNS label as well, and the port that you have exposed from your container to be exposed through outside world. So at this point, the port was 9090. We have that already up and running in Azure. If you wanted to query what the container is in a state, you could run the Azure Container Show and query the instance view.state. That will give you the current state of this particular container running in this particular container instance. So at the moment, you can see that it's in the running state. If I come back into my Azure portal and have a look at my NinjaCat ACI that we just created, there is a URL that I can use, or there is a external public IP address. So I'm just going to use the URL for this matter, copy that, create, bring a new tab, and remember we exposed port 1990. And when we do that, we get our NinjaCat application up and running in this ACI. So really easy way, and it didn't took us that long to create our container running inside this amazing service. And from here, you could have a look at the container, you could access the container logs, you could connect to the container using SSH, for example, and so on and so forth. So all the logs that are exposed from within your container is going to be written into the log console live. So when you go into different pages in your applications, if you have console logs, they're going to appear here. So I think this should be enough for this video.
Thanks for part one. So for those watching the video, please join us for part two, where Yas is going to cover off web apps for containers, Azure Batch and Batch Shipyard, and Service Fabric. See you in a minute in part two.